Good afternoon, ladies and gentlemen. This is Mr. Green. This is another of my lesson videos on Algebra 1. We're continuing to look at system of equations, and we're going to look at how to solve system of equations. Mr. Green told us that last time. It's where the lines intersect. But you know what? Unless you're a nerd like me and you carry around graph paper with you all the time, you might run into a system of equations that you're trying to solve and you don't have any graph paper. Well, you can kind of get close to it by, estimating it on paper and kind of drawing graph paper, but that gets messy, okay? And it's not always correct. So what we do is we have to say there's an algebraic method for doing it. One method of doing it is called substitution. We're going to take a variable and we're going to substitute it in for the other equation. What do you mean, Mr. Green? Well, let me just give you, I think if I work a couple examples, you'll see. Look at this system of equations. Two equations, both linear equations, and I'm trying to find the solution for it. I want you to notice something. They're both equal to y, aren't they? Well, if they're both equal to y, I could say that 2x plus 4, that's y, is equal to 3x plus 2. Well, that's y as well, isn't it? Now I've only got one variable in here. And if I subtract the 2x from both sides, right, I'm going to get 4 is equal to x plus 2. And subtract the 2 from both sides, I'm going to get that x is equal to 2. I've got a value for x now. I can go back up here to either one of these. As a matter of fact, we'll do it in both of them. And put that in. So I can have 2 times 2 plus 4. That's 4 plus 4. That's 8. Let's do it in the other one. 3 times 2 plus 2. That's 6 plus 2. That's 8 as well. So I got 8 for y. My point is going to be located at 2, 8. That was my x, y value. That's the point where these two lines intersect. Ta-da! That wasn't that difficult. And all I did was substitute this here, which was equal to y, into this equation for that. I substituted it in. You know, sometimes they don't give it to you in a way that it's real obvious. Okay? It's not real obvious what the substitution you're going to make is. Like this one right here. I want you to notice I've got a y all by itself here, but I got this 3x in here. If I do a little bit of work, y is equal to 6 plus 3x. Okay? That makes sense. Now I've got what y is equal to. I can substitute this into the other equation up here for y. Now watch this. Minus 5x plus 3 times 6 plus 3x equals 10. Distributive property. I'm going to multiply everything here by 3. Minus 5x plus 3 times 6 is 18 plus 3 times 3 is 9. 9x equals 10. Well, I've got a 5x and a 9x. I can combine those together. This is minus 5 plus 9, so that's going to give me a 4x plus 18 equals 10. I'm going to subtract the 18 from both sides of my equation, and I'm going to get 4x is equal to negative 8. I'm going to divide by 4, and I'm going to get x is equal to negative 2. Ta-da! Now I'm going to come right back up here to this one, to this equation right here. And I'm going to say y is equal to 6 plus 3 times negative 2. Well, 3 times negative 2 is negative 6. 6 plus 6, 6 minus 6 is 0. That's equal to 0. My point is going to be located at negative 2, 0. That's the point where both of these two will be equal to each other. You know what? Let's try that. If I stick this point into both of these two equations, see what I get. So I'm going to say negative 3 times 0 plus I'm sorry, negative 3 times negative 2 plus 0, that's negative, or that's a positive 6, is equal to, positive 6 is equal to 6. That's true. So I'm going to take it and plug it into this one up here. Negative 5 times negative 2 plus 3 times 0. Well, negative 5 times negative 2, that's 10. And that equals 10. So check. These two equaled the values that they've got there. They both equaled the values at that point. So I found a point that made both of these two both true equations at the same time. This would be my solution. Cool? Well, let's try and see a couple more situations. Hey, this one already has y equals to negative 2. This is going to be easy. 4x equals, 4x minus 7 times negative 2 equals 22. Well, that's 4x plus 14, because minus 7 times minus 2, or 7 times minus 2 is a negative 14. I'm subtracting negative 14, so that's going to be plus 14, equals 22. So I'm going to subtract 14 from both sides of this equation, and I'm going to get 4x is equal to, let's see here, 8. Let's see here, 14, 15, 16, 17, 18, 19, 20, 21, 22. Yep, that's 8. I have no shame. I used my fingers. I actually counted on my fingers. Yes, you can do that, okay? 8. So I'm going to divide by 4 in both of these two cases, and I'm going to get that x is equal to 2. I know what x is. So now it's a matter of plugging it back in. Oh, let's see here. Where would be a good place to plug this back in to find y? I got to go back to this equation here. It's the only one that has, well, I know what y is. Y is negative 2. So my point is going to be x comma negative x. My point is going to be at 2 comma negative 2. I'm going to check it in the equations. If I make negative 2 equals negative 2, check that one's going to work out. This one, I'm going to have 4 times 2 minus 7 times negative 2. Well, that's 4 times 2, that's 8. And this is going to be plus 14. That's equal to 22. 22 is equal to 22. Check, that one's true. I've made both equations true at the same time by using that point right there. Yay. Okay? Let me show you another one. This one, hey, I see a y right there all by itself. So I'm going to take 3x minus y equals 1. I'm going to add a y to both sides of the equation because I like having a positive y. And it's going to give me y plus 1 is equal to 3x. And so I'm going to subtract the 1 from both sides. I'll get 3x minus 1 is equal to y. I now have a value for y. Come to this other equation. Minus 6x plus 2 times 3x minus 1 is equal to 0. Distributive property. Minus 6x plus 6x minus 2. 6x plus 6x, that's 0. So I get minus 2 is equal to 0. Can we ever have minus 2 equal to 0? No. We can't ever do that. Did we do something wrong in our equations? No, not really. And what I want to show you is if I divide this by a negative, if I divide this by a negative 2, divided by negative 2, what am I going to get? I'm going to get 3x minus 1 equals 0. Look at these two equations. They're the same. These two lines are parallel. If I reach a situation where it is not possible, that must mean I have parallel lines, A-R-A-L-L-E-L, lines, and there is no solution. Okay? I wanted to show you. You could see it algebraically because I reached a point that was inconsistent. You can't get to this point. Negative 2 can't equal 0. Okay? Okay, let's look at a couple more here. So this one, they already gave me what x was equal to. I'm going to plug it into this equation. Y over 2 equals 2y minus 3 over 4 plus 3 over 4. You know what? I just truly dislike fractions. So I'm going to do something funny. I'm going to multiply by 4. I'm going to multiply that one by 4. I'm going to multiply that one by 4. I'm going to multiply that one by 4. Why did I pick 4? Because it was the denominator of these over here. Okay? 4 times 4, I'm sorry, 4 divided by 4 gives me 1, so what is this going to give me? 3. What's this one going to give me? 2y minus 3 is equal to, well, 4 goes into 2 2 times, 2 goes into 4 2 times. This is going to give me 2y. Well, that was easy. Now let's look here. Well, 3 minus 3, that's 0. And if I subtract 2y from both sides of this equation, I'm going to get 0 is equal to 0. Notice I did not get an inconsistency. I got an identity. It equals itself. It's reflective, right? That means same line. Okay? I'm trying to show you that even algebraically we can see that these are the same lines without even having to work it out. Cool? Hopefully you guys are seeing that. So, two situations. The lines either intersect and you'll get 1 point. The lines are parallel and you'll get an inconsistency and it can't happen. And so you say the lines are parallel. Or you'll get an identity and you'll say, oh, that means they're the same line. Okay? Cool. Hopefully you guys got this, and we'll talk about another way of doing it next time.